section 7.6, integration using tables and technology. Now sometimes what happens is that we are dealing with problems which are very lengthy, or whose integrals are, finding the integral is a cumbersome process. In those cases, we are allowed to use technology or tables if available. And in the exams, mostly you won't be asked, those type of questions where it's too much involved or too many steps. But in real life, or when you're doing homework problems, if in case you come across such problems, then you are allowed to use the technology or the tables. And when we are talking about the table in your book, there are tables which are called on reference pages, and we are referring to page 6 through 10, where you have bunch of integration formulas. And so for example, if you have a sine raised to the power 6x, now I already explained, whenever you have a sine, in the integrand you have a sine x function or a cosine x function, and you have an even power, you can use the formula, half angle formula, that using sine square x. So sine square x equals 1 minus cosine of 2x over 2, or if you want to look at it like, you can also think of it like, so sine square x equals 1 minus cosine 2x over 2, or 1/2 minus 1/2 cosine 2x. So whichever way you want to remember it. But if you have to do sine to the 4x, then you can write it as 1/2 minus 1/2 cosine of 2x whole squared, which is still manageable. But when it goes to sine 6x, then it means this quantity which we have whole raised to the power 3, and which is becoming now too much. Or even if you have sine to the 8 power or 10 power, so that's like too much. So in that case, we would like to use the formulas table, using the formulas from the table. And in order to do that, we have to look which formula we will be needing. So in this case, I showed you the formulas which are at the back of the book. So in this case, we will be needing formula number 73. So I'm going to say number 73, which says that integral of sine to the n u du. In the book, they are using u in general. This is equal to 1 over n sine inverse sine to the n minus 1 u, so 1 less power, plus times cosine of u, plus n minus 1 over n, and integral of sine to the n minus 2 of u du. So notice here we are using formula, but we are not done in one step. We still have to keep going. So let's see how we can apply this on our function. So in our case, you can notice that our n is 6, and in place of u, we have x. So that this thing, sine 6x dx, will become 1 over n. 1 over n means 1 over 6 in our case, sine raised to the power 5x times cosine of x, plus n minus 1 will be 5, so 5 over 6 integral of sine 4x dx. So now notice we have to apply the formula on sine 4x on this integral. So we will keep the first term as it is, plus 5 over 6, and now I'm going to put a bracket here because everything will be multiplied by 5 over 6. So apply the formula again. So now our n is 4. So we have 1 over 4 sine cube x times cosine x plus 3 over 4 integral of sine. So n was 4, so it becomes sine square x dx. So we write first term as it is and distribute the 5 over 6. So I get 5 over 24 sine cube x cosine x plus, so 3 goes into 6, so 5 over 8. And now I have this sine square x, which integral of sine square x, which you can find it by using our half angle formula, or you can actually apply this formula again. So if you apply this formula again, notice here our n is 2 now, so we'll end up getting 1 over 2 sine x, because n minus 1 will be just 1, times cosine of x plus 2 minus 1, so 1/2 times integral of sine to the 0x, or just dx. So now just clean it up. So 1 over 6 sine 5x cosine x plus 5 over 24 sine cube x cosine x plus 5 over 16 sine x cosine x, and then plus 5 over 16 and x, and then plus c. So that will be the final answer. Next is x cubed times arc sine x square. Now notice here, this is like a polynomial or a power function multiplied by an inverse sine function. But inside the inverse sine function, we have an x squared. So normally if you look up in the formulas, you won't find a formula directly for this. Normally it will be like a single variable here, u. So which suggests that we should make a substitution here. So we say let u equals x squared. And you might notice that we have an x cube outside. So how can that be handled? Well, let's try and we'll see what happens. So we will say x squared, then du is 2x dx. So which gives us dx is du over 2x. We come back here and replace. So I have x cubed. I am not going to replace it yet, but arc sine of u times dx is, we just saw du over 2x. So notice this x will cancel one of the x's in the x cube. So we have 1/2 integral of x squared sine inverse of u du. So we have two different variables, cannot integrate yet, have to get everything into one variable, and since we have du here, so everything should be in u. So 1/2 integral of, now we already know by the substitution that x square is u, so we can replace it by, okay, so now this looks something which we might be able to find in the formula. So if you now search for it, you will notice that you end up getting formula number 90. So number 90, which says integral of u sine inverse of u du is equal to 2u squared minus 1 over 4 sine inverse of u plus u times square root of 1 minus u squared over whole everything over 4. And then we can put up plus c. So now in our case, our x cube arc sine of x square dx will now become, so 1/2 times this quantity, because that's what we have exactly, So 2u squared minus 1 over 4 sine inverse of u plus u into 1 minus u squared over 4. But remember, our answer has to be in terms of x, so we go back and replace the u. So we end up getting, we can actually distribute this. I think this will be better. We distribute the 2. So up here we are getting 2 times x to the 4 minus 1, because u square will be x to the 4, whole divided by 8 sine inverse of u, which is x square. So sine inverse of x square plus x squared times square root of 1 minus x to the 4th whole divided by 8, because that 2 is distributed here as well. So this is the final answer. Okay, looking at the next example. Again, so this looks like this involves trig functions and then the logarithmic function. So we might have seen something like sine of x times ln of x, or cosine of x times ln of x, or maybe x ln of x or something like that, or x square ln of x. So it looks like this should be something like that. But like having sine of x inside ln of x, you won't find a formula in the table. So we need a substitution. So the substitution will be, the problem is suggesting you that take u to be equal to sine x. So which means dx is cosine of x dx. Coming back here, so we have sine square x times cosine of x and ln of sine x, which will become ln of u, and dx will be du over cosine x. Remember from here, this was du. So dx is du over cosine of x. Anyhow, so the cosine x and cosine x get cancelled. So again, we have sine square x times ln of u. Everything must be in u. So we replace your sine by u. So we get u squared ln of u du. So again, this problem is doable by integration by parts, but you might have to apply integration by parts at least maybe 2 times, maybe once. Well, you can try and see, but we will use the formula. So which formula here? So in this case, we will be looking at formula number 101, okay, which says that if you have u to the n times ln of u du, then the formula goes like this, that is u raised to the power n plus 1 over n plus 1 whole squared times n plus 1 ln of u minus 1 and then plus c. So notice here, this is one term and then minus 1 another term. There is no parentheses here because that will change the answer. So make sure you do not make that mistake. So in our case, our n is 2, so that our answer will be, so in our case we have u square ln of u du. So it will give us u to the third over 3 squared, which is 9, times 3 ln of u minus 1 plus c. And now go back, replace the u by sine x. So we get sine cube x over 9 times 3 ln of sine x minus 1. Okay, last question here. So we have again x to the 4 whole thing divided by x to the square root of x to the 10 minus 2. Again, if you look in your formula, so in the table, you will notice that you might have problems where inside the square root you have a single variable plus minus a number, or you might have like a x squared plus minus a, or you might have like an a plus or a squared plus minus x squared, but not x to the 5 or x to the 10. So which is suggesting that we should make a substitution here, and also there is a variable on the top which also suggesting what substitution should be made. Now x to the 4 you will get when you differentiate x to the 5. So this is suggesting that take u to be x to the 5. So then du is 4x to the 5x to the 4 dx. So that dx will be du over 5x to the 4th. Coming here, this becomes x to the 4th whole divided by square root of. Now if u is x to the 5, then x to the 10 will be u squared. So we get u squared minus 2 times du over 5x to the 4th. So this simplifies to 1 over 5 integral 1 over square root of u squared minus 2 du. So now what formula will be applied here? Well, there is formula number 43, which suggests that if you have du over square root of u squared minus a squared, then this will be equal to u over 2 square root of u squared minus a squared plus a squared over 2 ln of absolute value of u plus u squared minus a squared square root, and then plus c. So that in our case, because this is what we have, but instead of a we have instead of a squared we have 2. So u squared minus 2 will be u over 2 times square root of u squared minus a squared, which is 2, plus a squared, which is 2. So 2 over 2 ln of u plus square root of u squared minus a squared plus c. We now go back and replace our value for u, which was x to the 5th. So the 2 and 2 get cancelled. So that will be the final answer. So this is how you can apply the formulas from the table.